Okay, it says a mosquito collides head-on with a car traveling 60 miles per hour. How do you think the size of the force that the car exerts on the mosquito compares to the size of the force that the mosquito exerts on the car?
Okay, hang on just a sec.
That's just a thought question, right?
Yep, but it's a good question, right?
I mean, wouldn't it just be equal?
Yes.
Forces are equal. Okay, now
They're
what
trying
about
to trick
like,
you.
what about like acceleration?
Okay, so that's the difference. So you got a big truck.
I don't like it when they're trying to trick us.
Yeah, they're trying to trick you for sure. And you got this little mosquito, and they're gonna run into each other. So you got a truck here, mosquito, plow into each other. So on the mosquito, if you drew a free body diagram for that, you'd have force of the truck on mosquito, right?
Mm-hmm.
And on the truck, you would have force mosquito on truck. It'd be equal, right?
Yeah. Forces are the same.
Mm-hmm.
And then would it come down to mass?
Yeah, because now you take this and you say the force is an X for the truck, no, for the mosquito, equals force of truck on mosquito, equals the mass of the mosquito times its acceleration.
Force of truck on the mosquito equals.
The mass times acceleration, right? So this is just the force equals mass times acceleration.
Oh, so you're just doing it for one direction?
Just for the mosquito.
Oh, okay. Oh, okay.
And then you do it for the truck. So this is force of mosquito on truck equals mass of truck times acceleration of the truck.
Mm-hmm.
So now we can say, well, yeah, these are equal to each other, right? So the mass of the mosquito times the acceleration of the mosquito equals the mass of the truck times the acceleration of the truck.
That doesn't seem right, does it?
It is.
How does that work?
Because here, I'll show you. So
Okay.
you've got a tiny, tiny little acceleration here, or a tiny little mass, and a huge mass over here. So if you have a tiny mass and a huge mass on the other side, what do your accelerations have to be like?
Then the acceleration for the mosquito is going to be a lot bigger.
Yeah, so you have to have a tiny mass and a huge acceleration in order to get a huge mass and a tiny acceleration. So because of the masses, the acceleration of the mosquito is gigantic, where the acceleration of the truck is just, it doesn't even matter. So you'd end up with like, say, well, I don't even want to make up numbers for it because I think that would take longer than it was worth the time, but even though the force is exactly the same, this force acting on a mosquito does a ton of damage, while this force acting on a truck does nothing.
Oh, okay. That's weird.
Yeah, it's kind of weird, but it's true. That's how it works.
Okay, that makes sense. Okay. Cool, we just did that. Separate free body diagrams.
Yeah, so maybe if you think about, what if it was like a little rock instead of a mosquito? So if a rock comes and hits the windshield of a truck, does the rock like slow down the truck very much?
No.
No, it doesn't slow it down at all. The rock will go shooting off, but what can that little rock do to the windshield of the truck?
Crack it.
Yeah, so if this was a tiny little rock, you've got a force acting on the rock shooting it out. Because it's so tiny, it just shoots out. But there is a force here that, while it didn't slow down the truck, it does have the potential to like put a crack in the windshield or something like that. Because it does, I mean, safety glass in a windshield, it's actually pretty tough to crack. So there had to have been some kind of force there from that rock that cracked it.
Okay.
But it's just up to masses. That's what affects it.
Is there any more forces acting on the truck or the mosquito besides the main forces?
No. No, there wouldn't be. Yeah. Super
Okay.
easy.
Okay. Okay. Write the acceleration constraint in terms of components. For example, write a of 1 of x equals a of 2 y, if that is the appropriate answer, rather than a vector 1 equals a vector 2.
Okay.
Okay, what is a constraint?
So, so now you know that when two things are like touching, the forces are going to be the same. And that's going to be really helpful in solving these kinds of problems. But then there's one other thing that affects it as well. And that's if these two are tied together with the rope. Say this is a mass of 15 kilograms, and this is 150 kilograms. So we already decided that the tension between them is going to be equal, right?
Mm-hmm.
So if you're over here, you're pulling on this set system with however many newtons, the tension in between the two is the same, right? So then you
Yeah.
want to find tension.
So the tension would be the same because, why? Why would it be the same?
Okay, just because of that, they're reaction pairs, right? So let's kind of run through this problem
So
really
it's
quick.
like the forces.
This is 15 kilograms. Let's do it the way that we were just doing. So we're going to say this is a frictionless surface. And you've got somebody pushing with 300 newtons.
Mm-hmm.
And you want to find out what this force pair is. Okay?
Oh, okay.
So let's draw the free body diagrams for, let's call this A and B. So for A, you're going to have 300 newtons. And you're going to have the force of B on A.
Mm-hmm.
For B, you'll have the force of A on B. Right? That's the
Yeah.
same as what we just did. Now, but you want to solve for A on B. So you say, well, let's sum our forces in X. This is going to be equal to 300 minus force of B on A
Mm-hmm.
equals the mass of A times the acceleration of A. Right?
300 minus B on A equals.
So that's
Yes.
your net force equals your mass times your acceleration.
Mm-hmm.
And you do the same thing over here, except this time it's just FA on B equals the mass of B times the acceleration of B.
Okay.
So how many, and then we also know that FA on B equals FB on A, because they're being pushed, it's a reaction pair.
Mm-hmm.
So how many unknowns do we have?
B on A, A on B.
And then our accelerations.
Mm-hmm.
And then those show up in that. And then how many equations do we have?
Two.
Yeah, so we've got 3 equations with 4 unknowns, which means it's impossible to solve.
Mm-hmm.
So, what do we know about acceleration A and acceleration B though? If you're pushing these things along the floor.
Is it speeding up or constant speed?
It'd be speeding up most likely.
Well, they're probably equal,
Yeah.
right?
Because they're touching, right?
Yeah.
So if you take, it doesn't matter what it is. I mean, you could take a Mack truck and put like a bouncy ball in front of it. And if you push the two together, then they're gonna accelerate at the same rate.
Yeah.
So that's your last equation. You just say acceleration in A equals acceleration in B. Okay?
Yeah.
So that's an acceleration constraint. When two things are touching, they're moving together, or when two things are tied together. I think, aside from this one, but like all of these ones that are tied together with the rope, you're assuming that the rope isn't changing length, that it's always tight. So say you were lowering something, maybe you had like a grand piano, and underneath that you had like a fish bowl or something. Something really small. I don't know why you'd ever lower it that way, but you're moving and you're trying to lower your grand piano and your fish bowl out of your house. And they're tied together with ropes. How's the acceleration of these going to be related?
They're still going to be equal.
Yeah. So when they're tied together with rope, you just say that, okay, they're going to accelerate together because the rope isn't changing length.
Okay.
So that's why you find acceleration constraints, because now you can solve this problem using these four equations.
Okay, so on these questions then, what is it that it wants? Because I feel like it doesn't really ask for much, it just wants you to
Mhm.
say that all the accelerations are equal.
So it just wants that little acceleration equation. So this is just like the first one, right?
Like the first problem we did?
Yeah, this one right here
Mhm.
is the
Oh,
same
okay.
as the first one on
Yeah.
your page.
Mhm.
So this is block 1, this is block 2. So we said that acceleration 1 is equal to acceleration 2.
Yeah.
That's all it's asking for right there.
That's it?
Yep. And they say to do it like X or Y, so the acceleration in X is equal to the acceleration in X.
Why do they have X and Y on set points? Because that's like going this way and that way and go that way.
Yeah, so when you look at the next problem,
Oh,
we'll
okay.
see.
But really, that's like, I feel like they just gave me the answer for all of them by telling me how to do it.
Yeah. They're not super complicated. It's just finding which ones are going to accelerate together.